the function operations in math, that's just your basic add, subtract, multiply, divide. So if we're looking at doing function operations, I could have here, they're going to try to write this stuff confusing looking, but I could have a couple of functions. F of x is equal to 3 square roots of x, and g of x is equal to negative 10 square roots of x. Okay, so they give you two functions like this, and then they're going to say, this will be what the problem looks like. Okay, right down here where my mouse is hovering, that's what the problem will look like. So all that means is take your two functions and do what the sign in between these says. So I'm going to take my f function and I'm going to add that to my g function. So it's pretty stinking simple. F function plus g function, and I put that in parentheses only because of that negative. I didn't want that to confuse me. You don't have to put in parentheses. So we just took the f function, added that to the g function because that's what the problem said to do. Now, for me to be able to simplify this, they got to be like terms. So square root of x, square root of x. Check, check. Those are the same, right? So all you do is look at this and say, well, I got 3 of them plus negative 10 of them. So what's 3 plus negative 10? So negative 7 of them. That'd be your answer.
So that square root of x is the same.
Pretty simple. Okay, we could use those same two functions and say I want to subtract them. And also I kept the f and the g in the same order. You could flip them up. You could have done g minus f or whatever. But now I've got the same two functions and I want to do f, so I'll write the f first minus g. Okay, so now it's the same thing. I got like terms, square root of x, square root of x. 3 of them minus negative 10 of them. What's 3 minus negative 10? Positive 13. So that'd be it. So you can do any kind of operation that you want on them. Okay, let me give you another subtraction one with some different functions. Got what you need on that page? Let's say I had f of x is 2x cubed, making this one a little different, plus 4x squared minus 8x plus 4. G of x is 3x cubed minus 5x squared plus 6x minus 9. Directions on this say to find f minus g of x.
Will it always be something simple like that, or plus or minus?
We're going to do multiply and divide in a minute. Alright, so on this you could, you can do this several ways. F is the top one, so you could write all of it and then write minus that one. Since I know what I'm doing, I know I'm taking the F1 minus the G1, and all I can do is subtract like terms, right? I could just not even go through the agony of rewriting them and just look for like terms. Does that make sense? Like I could say 2x cubed minus 3x cubed. There's some like terms. So that would be negative x cubed. Okay, then I've got 4x squared minus negative 5x squared. You've got to be careful on those signs because remember it said to subtract. So 4 minus negative 5 gives me a positive 9 on my x squareds. Okay, what do you get on your x's? What's negative 8 minus 6? Negative 14. Because it's a negative minus. Yep. And then what about on your constant? What's 4 minus negative 9? So that'd be it. That'd be my answer for f minus g of x. Now, they could take this a step farther and tell us then to evaluate for f minus g of any number. I'm going to say negative 2. Okay? So see if they're on the right where I added on here f minus g of negative 2. Well, we've already found f minus g. So now all we're going to do is plug a negative 2 in for the x's and work it out. So that would look like negative 2 cubed plus 9 times negative 2 squared minus 14 times negative 2 plus 13. I just plug negative 2 in for all the x's. Okay, so first part there, negative 2 cubed is negative 8. But then I make it a negative, so it'll be 8. Negative 2 squared is 4. 4 times 9 is 36. Negative 14 times negative 2 is a positive 28. And then plus 13. So I'm going to say F, LSU minus G, of negative 2 is equal to, what do you get on all this? Say it again. 69 she thinks. See, 16, 6 and 8 is 44, 54, 64, 72.
Oh, no. 85.
I'm thinking it's 85. So what you got, Mason? What'd you do, Ben?
I don't know.
Yeah, I don't know. I reckon you just messed up. That happens to all of us. Somewhere in others. 85, 85. Alright, let's look at the multiplied one. Think how much you need on that one? Not too difficult. I'm going to say f of x is x cubed. G of x is the square root of x. When I want you to multiply, just put them right next to each other. G means f times g. So we're going to find f times g of x. Then in a minute, well, that's a different problem. Here we go on this one. Then in a minute, we'll evaluate for f times g of 4. But we got to get f times g of x first. Alright, so I'm going to take f, which is x cubed, and I'm going to multiply it by g, which is the square root of x. Alright, now, how in the world do you do that? When you got something with a power, and then you got something with a radical.
You have to cube the square root.
No?
Cube the square root of x.
No?
Square root of
Kinda. You're kinda on the right road. What we gotta do to be able to simplify this, we gotta have them both in exponent form or both in radical form. So I need to rewrite this either with the radical, both of them, or with the exponent in both of them. Okay, if I look at just the square root of x, there's no numbers written in that, but isn't that an understood x to the first power and an understood x, square root of x? So using power over root, wouldn't the square root of x be the same as x to the 1/2? And that's pretty important. Okay, so make sure you make you a note here like I did on that so you'll know. So now this x cubed, instead of times x, the square root of x, that's the same as times x to the 1/2, right? Because of the power over root stuff. Now, back to early last week, when I'm multiplying with the same base, what do you do with the powers? Add them is right. So I'm going to have x to the 3 plus 1/2. And what's 3 plus 1/2? 3.5. You could leave it like that. Since it's going to be an exponent, most of us will write it as 7/2 because it's power over root, but 3 1/2 is correct, so that would work. That's it. X to the 7/2. The only thing that worries me is that y'all will forget the square root of x. You'll forget how to rewrite that. So make sure you get you some notes. And you could do that for any root. If it had been the cube root of x, that's the same as x to the 1/3, right? If it had been the 4th root of x, that's the same as x to the 1/4. Remember, that's important, okay? All right, now, I also asked you a while ago to evaluate when x is 4. So now we just got to do 4 to the 7/2 power. You can do that on your calculator. I know the square root of 4 is 2, and 2 to the 7th, 2 times 2 is 4 times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, times 2 is 128. 128. Is that what y'all got in your calculator?
Well,
Sure.
Y'all can count by twos. Come on. That's all that was.
I know you just did. You were just like, I don't even know what you said. You said it so fast.
2 is 4 times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, times 2 is 128.
You sound like one of those robot machines. You sound like
Carolina
just like
doesn't
spits out
sound
information.
like. Except for we could actually somewhat understand you.
Like, what is it, those auctioneer people that have to talk about really fast? Yeah. You ever seen Sword Doors? I think that sounds cool. I wonder if they, like, talk that fast in real life. Or not in real life, but having a normal conversation.
Probably not.
No, I got an uncle that does auctions and he talks pretty slow normally.
Oh, really? I like them, like, talk like that, and if you got in a fight with somebody, you start telling them off, and then, like, start rolling off your tongue, like, really, really fast, and like, what?
Yeah, they didn't even know. They'd be like, no point. I told them off. Well, they didn't understand it. Alright, this time we are going to find f divided by g of x. And then in a little bit we'll evaluate that for x of 27. Alright, so divided by. So that means we got f divided by g right?
Would you multiply the top by an exponent of 2/3, and then multiply the bottom by 4?
No?
Would you multiply it by...
No? What's important here, back to your rules that we copied down off those pictures that I took, I've got division. What happens on exponents when it's division?
You subtract.
You subtract them. So that means I'm looking at the, what's the power understood on this 1? If there's, it's an understood 1, so I'm looking at 4x to the 1 minus 2/3. Okay, now, anybody know why it's 4x here?
Because the 4 and the x just like 4 divided by 1 is 4,
okay.
and x is 1.
Yeah, that's good. The x is your base, so you keep the base, and then 4 divided by 1 is 4. So that was right. What basis said on that? All right, now what's 1 minus 2/3? No. 1's like 3/3. So what's 3/3 minus 2/3?
1/3.
1/3 is correct. And that's it. Can't simplify that anymore.
Oh, I just...
Now you could. What were you trying to do? Power over root stuff? Oh,
No, I erased my problem by accident. I erased the wrong thing.
I don't accidentally erase stuff very often. All right, so we're good on that. It's right above it, 27. I couldn't see where I wrote what we were finding. So finding now 4 times 27 to the 1/3. Is that 1/3 on the 4 and the 27, or just the 27?
Just the 27.
Just the 27. Good job. Now remember, what is 1/3 the same as? The 1/3 power is the same as what root? Cube root. What's the cube root of 27? 3. Good, David. That's a common one. Y'all all need to know that. 3 cubed makes 27. So 3 times 4 is 12. You need to screw it up, Caitlin? Is that better?
Okay, I got it.
Okay. Alright, so we did some of it says perform function operations. We did all of them. So now let's look at inverses. Inverse is easy, but every year people just forget how to do it. Let's say I had a function f of x, start off with an easy one, equals 3x minus 1. The directions say to find the inverse. We know inverse, just the word, means opposite, right? Everybody okay on that? The inverse of something's the opposite. So what you're going to do when you find the inverse, step 1, you're going to switch your variables. And I'll show you what all this looks like. Step 2, you're going to solve for y. And that's it. I mean, it might take more than one step to solve it for y, but that's what we're going to do. Switch the variables and solve for y. So as it's written, it doesn't even look like there's a y in it at all. But where's the y in this? So this is the same as saying y equals 3x minus 1. Okay, so now step 1 says switch the variables. So I'm just going to interchange the y and the x. So I'm going to say x equals 3y minus 1. That was step 1, switch the variables. Pretty simple. Step 2, solve for y. So over here with my y, what would I do first to start trying to get it all by itself?
Add 1.
Add 1. So x plus 1 is equal to 3y. Then what? Divide by 3. Now what's x plus 1 divided by 3? I don't know. It's x plus 1 divided by 3. That's very easy. Now I circled that and I wrote that. There is a symbol for inverse. If we got fancy and wrote this in inverse notation, the inverse is the -1 up there.
Why is it negative?
I don't know. That's just the, I really don't. I'm not being sarcastic. I really don't. That's just the symbol for inverse.
So can we just say y then?
But if you see this, you need to know that that means the inverse. And there's a button, inverse button on the cup there. It won't do this for you, but there is an x to the -1 button somewhere on there.
What's inverse?
Oh, that's it.
Yep. That would be called inverse notation. And that one was just something that was linear, so let's expand our powers up a little bit. Everybody got what you need there? I got f of x equals x squared. It doesn't get much simpler than that. F of x equals x squared. Directions say find the inverse. So step 1, switch the variables. So what are you going to write for switch the variables?
So x equals y squared.
Now we need to solve it for y, and it's being squared. So Kylie's right. We undo the squared by square rooting. So the square root of x will equal y. I need to add one thing to that. When I square root something, it can be positive or negative. Very good. Most of the time I write my y first, so I'll do it like that. That's it.
Are you squaring the x equals y?
I squared it all. When I squared, I didn't square it, I square rooted it. Because when I square rooted the y, that canceled the squared out. So it's just a y now. The square root of y squared, the squared and the square root cancel out. Okay, let's add another power. Let's scoot it on up. I got f of x is equal to, I'm going to try this one by yourself, 2x cubed plus 1. Find the inverse of that. Go. Cube doesn't make it any harder.
You just take it with it.
Take it with it, I don't know what you mean.
Can you do the same with
Yeah, just.
Oh, it says with the x.
Look. I just now got what you meant when Kylie asked that. When you switch the variables, it stays on where it is.
Oh, so
So it'll be x equals 2y cubed, yes.
Okay.
I'm sorry.
You had it for a second.
So first thing that they were talking about when I changed this f of x to y, and I skipped that step on the last one, but y'all knew that. When I switch the variables, I'm just bringing the x alone out. So x equals 2y cubed plus 1. Okay, that's after you switch your variables. Now we're solving for y. So what would you do first to start getting the y by itself? So we subtract our 1. So we got x minus 1 equals 2y cubed. Divide by 2. So let's jump up here. Y cubed equals x minus 1 divided by 2. And do a cube by cube rooting. Good. So y would equal the cube root of x minus 1 over 2. Did anybody get there?
Yes.
Did you know what to do next?
There's another thing?
Circle it.
Oh.
That's
not funny, but
I got jokes. There was this one kid a couple of years ago who wanted to be good in math so bad, but he just wasn't. So the only thing he could ever get right was circle it. So we'd be working through a problem, and I'd say, what's next? And point it at him, and he would say, circle it! That was it. That was his plan to fame.
Did you pass your class?
Maybe barely. Circle it.
I bet you passed it by circling it in. Did you give him credit for circling?
No. Alright, now let's do one where it's got a radical in it.
Yay. Woohoo!
F of x is equal to 2 times the square root of x minus 3. Find the inverse.
We're doing it for ourselves? No.
I was going to do it with you, but if you want to try?
No.
Not really.
Okay. Alright, so first thing I'm going to do is rewrite that as y equals 2 times the square root of x minus 3. Now, step 1, switch your variables. So you got x equals 2 times the square root of y minus 3. Okay, now before, this is where I got a little tricked when I was looking through this on this morning, because I always look through it to make sure everything's cool in the mornings. But when we were solving these before, we always got rid of the extra junk there. So we would have divided by that 2. But that's not what we're going to do first this time. Okay, when we're finding the inverse on this, what we're going to do, when we're going to undo that squared now by squaring the whole thing. That was a little bit different, but that's going to get me, distribute that square to everything, so it's going to get me x squared, and look what it's going to do here. It's going to be a 4, right? And then what about here? What does the square and the square root do? Cancels out. Okay, now if I want to solve this for y, now what am I going to have to do next? No.
Add 3?
No. Good. I want to distribute that 4 there. So x squared equals 4y minus 3. Oh, no, it doesn't. Minus 12. Yep, you're right. Okay. Now, yes, add 12. X squared plus 12 equals 4y. You got one more step. What's the y going? Another 4. That'll be it. Now, other way you could write this, because you know since this whole thing is over 4, it means you divide each of them by 4. So 1x squared divided by 4, that could be 1/4, and then 12 divided by 4 would be 3. I don't require you to come here to this step, but those are the same. So if you like to see that on an ACT or something, you need to know those are the same. Let's see something. Alright, inverse, pretty simple, pretty easy.
Yeah.
What if you were given, one more thing here, what if you were given two functions? Oops, get it right with an eraser. F of x is 3x minus 1, and g of x is x plus 1 over 3, and it asks you if those are inverses of each other. What would you do to check and see if those are inverses of each other?
Would you just pick one and then
I didn't close up parentheses. I would, this one here would be the easiest looking since it's on a fraction. I'd find the inverse of it and see if it's this one, right? So let's see if they are. Y equals, I think we did this one earlier, but switch the variables. X equals 3, y minus 1. Add your 1. Divide by 3. So are those inverses? Did I get the same thing?
yes.
Yep. Yep.
Is that it?
That's it. That's all she wrote. Tomorrow I'll have a study guide for you. We'll do our test on Friday.